So guys, I'm gonna show you something about bonds. I'm gonna explain how to derive the price of zero coupon bonds from coupon bonds. So we have this bond called bond 1. You pay a certain amount. Let's say, let's do this table like this. So you have this bond 1. It's gonna cost you something. It's gonna give you $1. And then it's gonna give you 0.06 dollars at time 1. What's the price of this bond? Well, if interest rates, if in the yield curve the yield for 1 year, the yield for 1 year is 6%, then this bond is priced at par and x is equal 1. If the yield curve was not like this, but like this, then this would be a premium bond. It would cost more than 1. And if the curve was like this, interest rates higher than 6%, it would be a discount bond and would cost less than 1. So now we have a bond, another bond in this economy, bond 2, costs x, and you get 0.07, and then you get, again, 0.07 and $1. So we go here in the 2-year maturity, and if at 2 year we are at 7%, well, this this bond should cost 1. Just following what I was saying before. And now we want to create zero coupon bonds out of this economy. It's very easy. So we strip out this coupon here, the 0.06. We want a bullet pays only the principal of 1. What is the price of getting 1? Well, in absence of arbitrage, it should be exactly proportional to this. If I pay 1 and I get 1.06, I pay 1 and I get 1.06, then if I get 1, I get 1 divided by 1.06, which is 0.9434. Now, we want to create a zero coupon bond that costs something, gives you $0 time 1, and then gives you $1 at time 2. Well, how do we get to this bond? I'm just thinking right now because I'm not sure about what I said before about pricing at par. So let's have a look into that. So pricing at par, it would mean that $1 is equal to 0.07 discounted 1 plus y plus 1.07 discounted 1 plus y, and this internal rate of return does not give me actually, this internal rate of return is 7% if it's priced at par. But this 7% is not the yield curve at time 2. So be careful about what I said. And I will not explain this now, but going back to our zero coupon bond at time 2, well, in absence of no arbitrage, we can get this price X quite easily. So if you think about it, this bond, zero coupon 2, is nothing but this bond B2 minus this bond Z1, such that these cancels out and this pays 1 instead of 1.07. So let's create now a bond 0.3, which costs a certain amount X, gives you 0, and then gives you 1.07 at end, and maturity 2. Well, this is easy. We just need to sell the amount of Z1 that will give us 0.07. So same as before, we know that 0.9434, or actually let's be more precise. We know that 1 gives you 1.06. So how much gives you 0.07? Well, it's 0.07 divided 1.06. It's 0.66, 0.066. Kind of like this new function from the iPad. And so we buy B2, but we sell this amount of Z1, or actually, or of B1, because B1 could be thought of as a 0. So we have that -1 plus 0.066 will give us 0 and then 1.07. So this X is actually equal to -1 plus 0.066. Oops. So it will cost 0.934. We'll get 0, and then we'll get 1.07. And then finally, we can get the price for a zero coupon bond maturity 2. That gives us only $1. So it's very easy. This is making everything go crazy. So now why does he put an 8 there? This is not reliable. Okay, this is wait, let's Let's delete this for a second. Don't need it anymore. Okay, so we're good with this. So the zero coupon bond at time 2, it's just 0.934 divided by 1.07. Because if we invest this to get 1.07, then this, it puts a 2 in front of it. Let's just solve it. Solve 0.873. Wow, what happened here? 0.873. This is the price of the zero coupon bond and maturity 2. Thank you guys, and I hope you liked it. Now you can derive any zero coupon bond, provided that you have a bond with coupon up to the maturity that you want your zero to. If you have a bond maturity 5, then you can get the zero coupon bond price maturity 5. And you can also get the yield curve maturity. But we'll correct what I was saying before about the internal rate of return and pricing at par. So if the internal rate of return is equal to the coupon, then it is priced at par and the price is 1. And I verified this here, finding this y, and then I get that y is exactly 0.07 after these boring calculations. So it is indeed priced at par, and the price is indeed 1, detailed that I skipped above. But this doesn't mean that y2 is equal to 7%. In fact, it's not. If we want to find y2, we need to do a different step. And here I had made some calculations, but they were mostly confusional. But basically, we have to do the exact same thing as for the IRR, just that here we have 2 different rates. We have 0.07 that gets discounted by the y1 rate, 1 plus y1, and then we have our 1.07 that gets discounted by 1 plus y2 squared, and it should give us 1. And well, we need to solve a polynomial for this. And, well, we can do this together. I'm going to try to be quick. So in the denominator, we can write this like this. I'm just going to call it y for now. Oops. This is a bit too big. And above we have 0. Oh my god. Sorry guys. These notes have definitely some problems. Or maybe it's me that cannot use them properly. Sorry if I'm not talking a lot here, but this is boring. Here we go. Solve this very quickly. This, let's remove it. Because we just multiply by 0, we have on the y squares we have 0.99y squared. Then we have 1.98y. And then we have 1.13 minus 1.13 minus 1.1342 minus, don't know if I made a mistake here, but oh yes, I made a mistake. 1.1342 plus 0.07 minus 1.06, 1442. Okay, and then discriminant analysis, the delta. What I learned in math at school. Minus 1.98 plus square root of minus 1.98 squared minus 4 plus 4.099, 0.1442. Yes, that's it. Divided by 1.98. How much is that? $0.7035. We can say that it's approximately 7.04%, and that is Y2, which is different from the IRRY.